welcome to my channel. If this is your first time visiting, it's a pleasure to meet you. And if you're returning, it's wonderful to see you again. In this nonsensical lecture, we embark on a journey through the intricate, imaginary, and undeniably whimsical world of chemistry, a realm where logic and fact gently step aside, allowing imagination to take the wheel and guide us through molecular marvels that exist only in the space between waking and dreaming. As you settle into your cozy space, let the weight of the day dissolve like a sugar cube in a glass of lukewarm helium, and allow your mind to drift softly, effortlessly, into the warm embrace of atomic nonsense. Before we begin, if you find comfort in softly spoken nonsense, and if drifting off to imaginary molecules and unreal reactions brings you peace, I gently invite you to like this video. And if you'd like more sleep-inducing lectures that make absolutely no sense at all, consider subscribing to the channel. It is a huge help, and I'd love to see you here again. If you're curious about how this video was made, including the tools that helped bring it to life, you'll find a quiet explanation waiting for you in the video description. Now, picture, if you will, a vast and sprawling laboratory, one that stretches beyond the boundaries of what is scientifically possible, where beakers bubble with dreams and flasks fizz with forgotten thoughts. Here, molecules mingle like guests at an elaborate banquet, exchanging subatomic gossip about the latest quantum entanglements. Electrons flit about, whispering secrets to protons who nod politely, though they seldom remember the details. Neutrons, ever the diplomats, maintain a serene silence, quietly observing the dance of atomic absurdity unfold before them. In this realm, the periodic table does not stand still. Oh no, it waltzes. It glides gracefully through dimensions unknown, shifting its elements into new and unfamiliar configurations, where noble gases occasionally step down from their lofty pedestals to host tea parties for wayward ions. Hydrogen, the eternal wanderer, often spins tales of its adventures across the cosmos to wide-eyed helium atoms who listen with rapt attention, their orbits twinkling with curiosity. As you journey deeper into this fantastical laboratory, you may notice the peculiar aroma of molecular contemplation, a delicate scent composed of equal parts wistful quarks and nostalgic neutrinos. It lingers gently in the air, wrapping around you like a warm, invisible blanket, inviting you to explore the boundless landscapes where atomic daydreams unfold. Listen closely, and you might hear the faint hum of photon lullabies drifting softly through the ether. These gentle vibrations resonate at frequencies only understood by drowsy positrons and sleepy gluons. each tone coaxing even the most restless electrons to settle into their respective orbitals for a night of uninterrupted slumber. We will explore concepts that lie beyond the boundaries of conventional understanding, concepts like the phenomenon of quantum fluffiness, where particles, tired of maintaining their rigorous structure, allow their waveforms to stretch and yawn lazily, creating a cosmic lullaby that echoes through the molecular ether. Or perhaps we'll delve into the elusive nature of bosonic sighs, those faint, almost imperceptible pulses of theoretical nostalgia emitted by atoms who momentarily pause to ponder their existence. We may also find ourselves wandering through the ethereal fields of proton procrastination, where positively charged particles linger aimlessly, postponing their inevitable interactions by engaging in philosophical debates on the nature of entropy. And let us not forget the mysterious land of catalytic serenity, where enzymes sip chamomile tea while coaxing reluctant reactants into forming bonds as gently as a breeze, nudging two leaves to dance. But before we delve too deeply into the wonders of atomic absurdity, I invite you to pause, to breathe, and to let the soothing current of molecular musings wash over you. Close your eyes if you wish, and allow your mind to settle like a carbon atom finding its place in a lattice of crystalline dreams. Feel the gentle pull of gravitational whimsy tugging at your consciousness, drawing you ever deeper into a state of tranquil surrender. The beauty of tonight's lecture is not in the facts, but in the fiction, where imaginary elements drift lazily through the fabric of space, where electrons and protons gossip like old friends, and where the laws of thermodynamics take a well-deserved nap. So, let go of expectations, release the need for logic, and allow yourself to become weightless, carried effortlessly by the soft, undulating waves of molecular nonsense. As the world outside grows quieter and the gentle hum of subatomic serenity fills the air, you are invited to join me on this fantastical odyssey, a journey where reality loosens its grip and the universe unfolds in whimsical wonder. The atoms are ready, the molecules are murmuring, and the periodic table is stretching its legs in anticipation. So, dear listener, relax, breathe deeply, and let us begin. Section 1: The Dance of the Electrons. Imagine a ballroom, vast and endless, where electrons gather to twirl and spin gracefully around the nucleus, their steps dictated not by Newtonian physics, but by an ancient rhythm known only to the subatomic world. These electrons, adorned in shimmering quantum gowns, waltz along invisible paths, tracing delicate patterns of probability and possibility. Each orbit is a whisper, a sigh, a fleeting moment of grace, where the boundaries between matter and energy blur into a fog of uncertainty. Occasionally, an excited electron might leap to a higher energy level, momentarily trading its steady waltz for a lively polka before cascading back down, releasing a tiny photon, a radiant burst of light, the atomic equivalent of a round of applause from the universe. And when two electrons, weary of their independent spins, decide to pair up in a delicate embrace, they create a harmonious duet that resonates through the molecular ether. The nucleus watches silently, the stoic chaperone of this cosmic dance, as protons and neutrons hum softly, providing a steady baseline to the electron's ethereal melody. If you listen closely, you might even hear the distant echoes of positron giggles as they flutter through the void, like tiny cosmic butterflies brushing against the edges of perception. Section 2: The Whispering Bonds of Molecular Longing. In the quiet corners of the molecular universe, atoms yearn for connection. They reach out with unseen hands, seeking companionship in the form of covalent bonds, where electrons are shared like whispered secrets between old friends. These bonds, delicate and invisible, hum softly with the promise of stability as hydrogen and oxygen join forces to compose the timeless ballad of H2O. But not all bonds are content with mere sharing. Ionic bonds prefer a more dramatic arrangement, a passionate exchange where one atom relinquishes its electron entirely, gifting it to another who graciously accepts, creating a magnetic tension that binds them together. This relationship, though charged with intensity, is a tale of opposites attracting, where positive and negative ions cling to one another in an eternal embrace. And then there are the van der Waals forces, those shy, fleeting attractions that emerge when molecules brush past each other, exchanging gentle, imperceptible glances. These forces, so subtle they are almost imaginary, create a quiet tension that holds the world together, like the delicate threads of a spider's web, barely visible but infinitely strong. Section 3: The Lullaby of Entropic Surrender. Entropy, the quiet architect of cosmic chaos, hums a gentle lullaby to the universe. It is a song that guides all things toward disorder, coaxing molecules to relax, to let go, to dissolve into a state of blissful randomness. In this serene unraveling, complex structures unwind like sleepy vines, stretching toward the comforting embrace of equilibrium. Picture a row of neatly aligned molecules, once brimming with purpose and precision, now succumbing to the soft pull of entropic ease. They lean lazily against one another, their bonds loosening as they drift into a state of molecular daydreaming. Even the most disciplined crystals eventually yield, their orderly lattice giving way to a gentle cascade of atomic indifference. This gradual surrender is not a collapse, but a quiet exhale, a sigh of relief as the universe gently whispers, "Rest now, let go. Everything dissolves in time." Section 4. The Adventures of Photonic Wanderers. Photons, those intrepid explorers of the quantum realm, journey tirelessly across the vastness of space, carrying with them packets of light and warmth. These travelers, though weightless, are burdened with the responsibility of illuminating the universe, painting the cosmos with hues of radiant energy. Some photons are born from the fiery hearts of distant stars, while others emerge from the humble collisions of electrons seeking momentary excitement. Regardless of their origins, all photons share a common purpose: to explore, to traverse the void at unimaginable speeds, and to whisper stories of distant galaxies to anyone willing to listen. Occasionally, a photon may choose to linger, to pause and reflect upon its travels, settling momentarily within the delicate embrace of a chlorophyll molecule, where it gently coaxes electrons to embark on their own journeys of excitation. And when its mission is complete, the photon departs quietly, leaving behind a faint glow, a soft memory of its presence in the fabric of time. Section 5. The Curious Case of Atomic Napping. Atoms, despite their ceaseless motion and boundless energy, occasionally indulge in a phenomenon known as atomic napping. This is a moment when protons, neutrons, and electrons agree, if only for a fleeting instant, to take a collective pause, to rest their wave functions, and drift gently into a state of subatomic slumber. During these microscopic naps, the boundaries between particles blur, and their positions become indistinct, as if they are stretching out across dimensions, allowing themselves to breathe and unwind. In this ethereal state, atoms dream of fusion and fission, of potential bonds yet to be formed, and of molecular adventures that await beyond the confines of their current existence. It is said that when atoms nap, the universe itself exhales, creating a gentle ripple through space-time, a wave of relaxation that invites every particle to momentarily forget its responsibilities and simply be. Section 6. The Garden of Quantum Possibilities. Deep within the folds of reality lies the Garden of Quantum Possibilities, a place where wave functions blossom like exotic flowers, each one representing a different potential state of existence. In this garden, Schrodinger's cat naps peacefully, neither alive nor dead, but simply basking in the soft glow of quantum ambiguity. The garden is tended by the enigmatic hand of probability, which prunes away deterministic outcomes, allowing only the most whimsical possibilities to take root and flourish. It is here that particles flirt with duality, existing as both waves and points, sipping gently from the fountain of uncertainty, while contemplating whether to collapse into one state or another. As you stroll through this ethereal landscape, you might notice the soft rustling of quantum leaves, whispering secrets of superposition and entanglement, concepts that tangle and twist like vines in a cosmic breeze. Section 7. The story of proton procrastination. Protons, despite their role as the backbone of atomic structure, are not immune to the occasional bout of procrastination. When faced with the daunting task of maintaining nuclear stability, some protons prefer to delay their duties by engaging in leisurely debates with neighboring quarks. These discussions, which often revolve around the nature of mass and the meaning of strong interactions, are punctuated by long pauses, moments where the protons allow themselves to drift into theoretical contemplation. During these interludes, gluons flit about like messengers, gently reminding the protons that their presence is required in the nucleus. But the protons simply wave them away, lost in thought. Eventually, of course, the protons return to their responsibilities, ensuring that the atomic nucleus remains intact, but not before indulging in one last, lingering moment of introspective delay. Section 8. The Enigma of Molecular Daydreaming. Molecules, when left to their own devices, are prone to fits of molecular daydreaming, a phenomenon where atoms momentarily lose themselves in thought, allowing their bonds to loosen just enough to teeter on the edge of dissociation. During these moments, the molecules conjure elaborate fantasies of alternative configurations, imagining themselves as complex polymers, elegant crystals, or even clouds of free-floating ions. As they drift through these dreams, the molecules hum softly, producing vibrations that ripple gently through the ether. These harmonic murmurs, though imperceptible to the human ear, echo across the molecular landscape, inspiring neighboring compounds to indulge in their own flights of chemical fancy. And so the cycle continues, molecules dreaming of what could be, and the universe quietly listening, savoring the stories woven from molecular imagination. Section 9. The Symmetry of Elemental Whispers. In the stillness of the atomic cosmos, elemental whispers echo softly through the void. These gentle murmurs originate from the periodic table itself, where each element sings its own unique lullaby, a quiet ode to its atomic identity. Helium, ever the introverted noble gas, hums a melancholic tune of solitude, while carbon, versatile and social, composes complex harmonies that resonate with endless possibilities. Even the rare and fleeting elements at the bottom of the table contribute their own fleeting notes, adding a subtle depth to this atomic symphony. These whispers, though subtle, ripple through the fabric of space-time, creating an invisible harmony that binds the universe together, ensuring that even the tiniest particles feel a sense of belonging. Section 10. The Sunset of Atomic Reverie. As the night deepens, The universe itself drifts into a state of atomic reverie, a moment where protons, neutrons, and electrons collectively sigh and allow their waveforms to blur gently at the edges. In this state, time slows, and molecules surrender to the ebb and flow of quantum tranquility. The dance of particles becomes a lazy swirl, a cosmic lullaby that rocks the fabric of reality to sleep. Entropy, ever the patient guide, whispers softly in the background, encouraging all things to relax, to dissolve, to return to the comforting embrace of randomness. And as the universe dreams, so do you. Section 11. The Chronicles of the Carbon Constellation. High above the molecular landscape, nestled between the clouds of interstellar dust and the yawning stretches of cosmic silence, lies the carbon constellation, an intricate web of carbon atoms woven together in patterns of impossible symmetry. Here, graphite sheets ripple softly, whispering secrets of lubrication and conductivity, while diamond lattices sparkle like frozen starlight, their bonds humming with crystalline serenity. These structures, though seemingly immobile, are perpetually engaged in a silent conversation, a philosophical exchange where graphene ponders the weight of its two-dimensional existence, while buckyballs roll lazily through the void, contemplating the geometric elegance of their 60-carbon embrace. Even the nanotubes, those slender sentinels of strength, murmur softly as they stretch toward the infinite, whispering tales of tensile dreams and molecular ambition. And if you listen closely, you might hear the gentle rustling of carbon chains rearranging themselves, forming organic compounds that drift lazily through the ether, each one a tiny fragment of cosmic poetry, awaiting its moment to join the symphony of life. Section 12. The Alchemy of Atomic Whispers. Deep within the quiet recesses of the periodic table, alchemy still lingers, not the medieval kind that sought gold from lead, but a subtler, softer form of transmutation where atoms exchange glances and secrets, transforming not matter, but possibility. This is where elements, tired of their atomic identities, daydream of becoming something more, where sodium imagines itself as a noble gas, and fluorine, ever the overachiever, dreams of gaining just one more electron to complete its outer shell. These whispered desires echo softly through the atomic ether, creating ripples that gently nudge the universe toward transformation. Occasionally, under just the right conditions, perhaps when a supernova sighs or a star's core grows weary of its fusion, the element's wishes are granted. Protons and neutrons shuffle positions like dancers changing partners, and new elements emerge, blinking sleepily into existence, unsure of their place in the cosmic order. Even now, in the quiet spaces between reactions, These atomic whispers continue, murmuring softly in languages that only the universe truly understands. Section 13. The slumber of the noble gases. In the dim corners of the periodic table, where the noble gases reside, a profound stillness lingers. These elements, helium, neon, argon, krypton, xenon, and radon, exist in a perpetual state of atomic tranquility. Their outer shells so perfectly content that they have little interest in bonding or engaging in the hustle and bustle of chemical interactions. They drift through the void like celestial monks, observing the chaos of the molecular world with serene indifference. Helium, ever the lightest of the nobles, floats effortlessly, humming a soft lullaby that echoes through the cosmos. Neon, with its gentle glow, bathes the night in quiet luminescence, while argon, heavier and more contemplative, mulls over the mysteries of ionization with the patience of an ancient sage. Krypton, xenon, and radon, though more reserved, occasionally allow themselves to be coaxed into fleeting moments of molecular dalliance, creating exotic compounds that dissolve as quickly as they form. But most of the time, the noble gases prefer solitude, gently reminding the universe that sometimes doing nothing at all is the most profound action of all. Section 14. The dreams of dissolved molecules. When molecules dissolve, they do not simply vanish. They embark on a journey into the unknown, drifting apart like weary travelers seeking rest. Water, the ever-accommodating host, welcomes these molecules with open arms, cradling them gently as they spread out, becoming one with the liquid landscape. But in this dissolution, molecules dream. Sodium and chloride, once bonded in crystalline rigidity, now find themselves floating freely, exploring the fluid embrace of aqueous existence. Glucose molecules, relieved of the burden of their solid form, weave elaborate fantasies of fermentation and energy production, imagining themselves transformed into pyruvate or ethanol, dancing through the metabolic pathways of unseen organisms. Even the most stoic of molecules cannot resist the temptation to daydream in solution, drifting gently in their newfound freedom, lulled by the soft, rhythmic currents that carry them ever deeper into the unknown. Section 15. The Symphony of Vibrational Echoes. Within every molecule, a symphony unfolds, a chorus of vibrational echoes that hum softly through the atomic lattice. Bonds stretch and compress like violin strings, their frequencies resonating in delicate harmony as molecules engage in an endless dance of motion. These vibrations, though invisible to the naked eye, create a molecular melody that reverberates through the fabric of matter, stretches and bends, twists and wobbles. Each vibration adds a note to this quantum symphony. The oxygen-hydrogen bond in water hums softly, like a distant cello murmuring tales of cohesion and surface tension. Carbon-carbon bonds resonate with a lively energy, plucking at the strings of organic chemistry like a nimble guitarist. And as infrared waves gently brush against these molecules, the vibrations respond, absorbing and releasing energy in a delicate exchange that echoes softly through the microscopic realm. A lullaby sung by matter itself, serenading the universe into stillness. Section 16. The quantum gossip of subatomic particles. In the minuscule realms where quarks and gluons gather, gossip flows as freely as virtual particles popping in and out of existence. Protons and neutrons, bound tightly within the atomic nucleus, exchange furtive glances, occasionally engaging in whispered conversations, carried by mesons flitting between them like cosmic messengers. Electrons, ever the mischief makers, eavesdrop on these exchanges, occasionally interjecting with their own tales of orbital adventures and quantum uncertainty. They speak in hushed tones of wave-particle duality, of collapsing wave functions and entanglements that span across space and time. And then there are the neutrinos, silent wanderers who drift through the universe, barely noticed yet, privy to the secrets of the cosmos. They glide effortlessly through matter, carrying with them echoes of distant supernovae and cosmic events that transpired eons ago. Though they rarely speak, their presence is a quiet reminder that even the most fleeting particles can leave lasting impressions. Section 17. The curious case of the sleeping catalyst. Catalysts, those tireless facilitators of chemical change, occasionally indulge in moments of quiet repose. Though they rarely take center stage in reactions, they are the unseen orchestrators, guiding molecules toward their destined transformations with a gentle nudge. But even catalysts, despite their relentless efficiency, need to rest. When a catalyst sleeps, it drifts into a state of molecular dormancy, its surface atoms rearranging themselves into a more comfortable configuration. In this slumber, the catalyst dreams of binding affinities and activation energies, of transition states traversed and barriers overcome. Enzymes, those biological catalysts, dream of substrate locking embraces and allosteric whispers that guide metabolic pathways toward equilibrium. And when the catalyst awakens, refreshed and ready, it resumes its task without complaint, ever the patient guide, ushering molecules toward their inevitable fates. Section 18. The magnetic murmurs of paramagnetic particles. In the quiet corners of the molecular world, where unpaired electrons linger, a faint murmur can be heard, the whispers of paramagnetic particles as they respond to the unseen caress of magnetic fields. These particles, though seemingly aloof, are drawn gently toward magnetic influences, their spins aligning in delicate harmony. Iron, cobalt, and nickel, ever the magnetic romantics, engage in quiet courtships with magnetic fields, their electrons twirling like dancers caught in a magnetic embrace. The unpaired electrons, like restless dreamers, oscillate softly between alignment and randomness, creating a gentle murmur that permeates the surrounding space. Even molecules with fleeting paramagnetic tendencies hum softly in response, their electrons whispering secrets of magnetic susceptibility, adding a quiet note to the universal symphony of attraction. Section 19. The muted laughter of isotopic twins. Isotopes, those subtle variations of atomic identity, exist in a state of quiet amusement, like identical twins who delight in playing tricks on unsuspecting observers. Though they share the same atomic number, these siblings differ in their neutron count, giving rise to variations in mass that subtly influence their behavior. Hydrogen, ever the mischievous element, boasts three isotopic identities: protium, deuterium, and tritium, each one carrying a slightly different story within its nucleus. Deuterium, the heavier of the trio, moves through the molecular world with a slightly more deliberate grace, while tritium, unstable and ever decaying, whispers softly of radioactive dreams. And yet, despite their differences, these isotopic twins move through the universe with a shared purpose, reminding us that even the slightest variations can give rise to an endless spectrum of possibilities. Section 20. The dreamscape of surfactant slumbers. Surfactants, those boundary-crossing molecules that straddle the line between hydrophobia and hydrophilia, drift into a state of molecular slumber where interfaces blur and emulsions dream of stability. In this dreamscape, nacelles gather like sleepy sentinels, their hydrophobic cores nestled safely within a hydrophilic embrace. Within these aqueous reveries, surfactants daydream of reducing surface tension, of coaxing oil and water into improbable unions. They imagine themselves as molecular matchmakers, facilitating liaisons between polar and nonpolar substances, creating emulsions that drift lazily through the fluid world. As they drift deeper into this slumber, surfactants hum softly, their molecular voices blending into a lullaby of interfacial harmony, where polar heads and nonpolar tails sway gently in an endless, dreamy dance. Section 21. The thermodynamic tea party. In a forgotten quadrant of the lab, beyond the Beaker Woods and through the glassware glen, the laws of thermodynamics host a tea party. Entropy, in a slightly crumpled waistcoat, pours lukewarm tea into tiny flasks, all while giggling quietly to itself about inevitable disorder. Enthalpy arrives fashionably late, trailing a shawl made of potential energy and waving lazily at the kettles. Gibbs free energy sits awkwardly on a tripod stool, unsure whether to stay or leave, muttering something about spontaneity and social anxiety. Temperature stirs its cup with a pipette, and pressure, always dramatic, presses everyone to sit in exactly the right volume. Meanwhile, the ideal gas law is telling riddles no one quite understands. What do you get when you cross an isothermal expansion with a reversible reaction? No one answers. The cookies melt, and the molecules? They mingle politely, exchanging exothermic anecdotes before drifting apart, lost in tea steam and gentle exclamations of DS. Section 22. The Secret Garden of Spectroscopy. Hidden behind the ultraviolet curtain lies a garden tended by invisible photons. In this spectral sanctuary, molecules bloom in absorbance and fluoresce in radiant shades of forbidden wavelengths. Infrared vines curl around rotational hedges, while NMR butterflies flit between magnetic petals, recording the quiet spin of nuclei. The garden is humming with quiet, orderly nonsense. Electrons climb vibrational trellises, hop energy fences, and sometimes, if the light is just wrong enough, they fall back down in a lazy spiral, sighing a soft, photoluminescent glow. Time dilates here, peaks broaden, and chemical shifts lie scattered like forgotten sandals beneath benzene bushes. The gardener, of course, is invisible, a soft, undetectable hand that nudges the spectrum this way and that. No one sees them, but every spectrum is a thank you card, signed in wiggly lines and unreadable units. Section 23. The Romantic Life of a Valence Shell. Some electrons just want to be loved. Tucked gently into their valence shells, they wait patiently for a bond to call their own. Sometimes they pair up, forming tidy little duets with perfect anti-parallel spins. Other times, they remain lone wolves, brooding in their orbitals, whispering to themselves about electronegativity and the one that got away. In this molecular rom-com, covalent bonding is a dinner date, two atoms sharing just the right amount of their inner secrets. Ionic bonds are whirlwind marriages, dramatic and full of charges. Metallic bonds? An ongoing group hug with communal electrons floating like glitter at a middle school dance. And sometimes the orbitals themselves twist into shapes. Sp-cubed doing yoga, d orbitals tangoing, and hybridized clouds sighing through resonance. It's all terribly dramatic. But in the end, every valence shell just wants what we all want: stability, preferably octet. Section 24. The Philosophical Musings of pH. Somewhere between acid and base lies the philosophical mind of pH, reclining on a litmus chaise lounge, pondering the fluid nature of identity. What is acidity, truly? It asks, stirring a beaker of lemony thought. Am I basic because I give nothing away? or acidic because I offer my protons too freely. Nearby, hydrogen ions sit in a circle, discussing self-actualization and dissociation. Hydroxide ions read old poems by Arrhenius, while Bronsted-Lowry definitions are debated quietly by candlelight. The buffer solution watches over it all, calm and emotionally stable, despite the existential tension. And above them, the scale itself trembles gently between 0 and 14, occasionally drifting just slightly outside, whispering, "I contain multitudes." Section 25. The Great Polymer Picnic. On the rolling hills of molecular possibility, the polymers are having a picnic. Long chains stretch out across the grass, links lounging comfortably beside one another, passing monomer snacks and telling cross-linking stories. Nylon braids daisy chains. Polyethylene wears sunblock. Acrylics giggle at polyester's sun hat, while proteins and polysaccharides sneak away for a quiet chat about enzymatic gossip. Somewhere nearby, a rogue thermoplastic melts into the lemonade, but no one minds. It's just another warm day in the land of repeating units. Even the synthetic rubber bounces in slow motion, a rhythmic boing-boing of relaxation. Every bond is relaxed, every structure at ease, and the only reaction happening here is joy. Section 26. The Elemental Lounge. Down at the base of the periodic tower is a lounge lit with soft ionization energy. Neon signs glow in noble configurations, and the walls pulse with the low-frequency rhythm of atomic orbitals. Elements lean on the bar, exchanging atomic numbers and tales of recent reactions. Lithium orders something sparkly. Sulfur sulks in a dim booth, reminiscing about its complicated relationship with hydrogen. Technetium, as usual, can't stay for long, unstable and unpredictable. And francium? No one's actually seen her in years. She's more legend than presence. The bartender, Carbon, serves drinks that fit every taste, organic or not. Oxygen flirts easily, but has trouble committing without a good hydrogen. And all the halogens? They're on edge. They always are. Section 27. The Soap Opera of Solubility. Welcome to As the Solvent Turns, where relationships are governed by polarity and everything depends on whether like dissolves like. Today, ethanol is caught between two worlds, its hydrophobic tail whispering secrets to oil, while its polar head is drawn irresistibly to water's hydrogen bonds. Meanwhile, poor sodium nitrate dissolves effortlessly in water, but potassium hexacyanoferrate isn't so sure. Solubility tables are rewritten, precipitates form, and somewhere, behind a curtain of volumetric tears, a salute cries, "I was saturated before you even stirred me." The drama never ends. Suspensions rise. Colloids cloud. But eventually, everything settles, unless you shake it. Section 28. The Lazy Electrons Guide to Excitation. Some electrons are just not in the mood to be excited. They sit in their ground state, sipping orbitals like soup, refusing photons with a polite, maybe later. Occasionally, a particularly persuasive photon tickles their energy levels, prompting a yawn and a tiny hop to the next orbital. But it's never long before they fall back down again, emitting a sleepy little photon on the way. This is how fluorescence dreams begin. Not with a bang, but with a shrug. Sometimes, an electron will get excited just enough to take a metaphorical vacation, slipping into a pi star orbital, sipping UV rays on an aromatic ring. But even then, it's all temporary. No one stays excited forever, not even in chemistry. Section 29. The Emotive Life of Mole Ratios. Mole ratios are the unsung love letters of chemical equations. They don't shout, they don't sparkle, but oh, how they care. They sit quietly between reactants and products, maintaining balance in a world of chaos. 2 of you for every 1 of me, they whisper. Let's make something beautiful together. Stoichiometry watches from a nearby shelf, gently nodding in approval. Sometimes mole ratios get jealous. Why does oxygen get 3 times as many? But mostly, they're content, knowing they're essential. Not flashy, just faithful. Section 30. The Gentle Decay of Time's Isotopes. Tick, tick, half-life. Somewhere, an isotope exhales a soft beta particle and leans back, 1 neutron lighter, a little more stable. Time moves differently for radioactive atoms. It drips, not ticks. A cesium sigh, a uranium shrug. They decay in whispers. Not because they're sad, but because they've seen things you wouldn't believe. Fusion reactions in collapsing stars, gamma rays slicing through eternity, lead nuclei dreaming of stillness. And so, they let go. Quietly, 1 alpha at a time. Section 31. The Quantum Cafe. In the far corner of the universe, at the edge of Heisenberg's uncertainty nap zone, there's a tiny cafe run entirely by quantum particles. The waiters are electrons, but you never know exactly where they are or how fast they're moving. The menu exists in a superposition of being both laminated and completely theoretical. Photons flit between tables, offering complimentary entanglement cookies. Once you take one, someone across the galaxy tastes chocolate. Neutrons hover silently in the background, contributing to the ambiance without adding any real flavor. The barista, a weary gluon named Gerald, holds the cafe together with charm and fundamental forces. No one orders anything. They simply observe and collapse the menu into existence. Section 32. The Stoichiometric Circus. Welcome, ladies and gentle-atoms, to the Stoichiometric Circus, where the laws of conservation perform impossible acts nightly. Watch in amazement as atoms are neither created nor destroyed, but simply balanced, sometimes on one leg, by the incredible ringmaster reaction. The mole clowns tumble in precise ratios, flipping from grams to moles and back again without a single calculation error. The molecule jugglers toss Avogadro's number like it's a feather. And don't miss the grand finale. The limiting reagent leaps through a fiery hoop of theoretical yield, bursting into confetti shaped like empirical formulas. No safety goggles required. This is nonsense chemistry at its most spectacular. Section 33. The dream of the displacement reaction. In a test tube deep in dreamland, a lonely single atom dreams of replacing someone. If only I were more reactive, it sighs, tracing its electron shell with a daydream. It watches a compound waltz by, two elements locked in ionic embrace. But then, suddenly, it happens. A swirl of nonsense, a puff of imaginary gas, and poof, the single atom is now bonded, beaming, whispering, I have displaced, and I feel whole. The old atom, now single, floats off on a pipette breeze, content in knowing that chemical relationships are temporary, reversible, and sometimes, just sometimes, symbolic nonsense. Section 34. The enzyme spa retreat. Imagine a quiet, bubbling spring nestled between catalytic cliffs. This is where enzymes come to relax after long days of lowering activation energies. Substrates line up for massages, sliding gently into active sites padded with velvet inhibitors. Allosteric modulators diffuse through the air, releasing calming aromas of competitive inhibition and mild pH adjustments. The masseuse, a serene coenzyme who speaks only in ionic hums. A TP flutters by, offering energy snacks wrapped in phosphates. And every now and then, a protein folds itself into a hammock and takes a nap, surrounded by chaperone molecules humming lullabies in tertiary structure. No kinetics, no fuss, just pure, non-functional relaxation. Section 35. The haunted flask of forgotten reagents. In the shadowy depths of the chemical cabinet, there lies a flask with no label. No one remembers who put it there or what it once contained. Inside, swirls of translucent nonsense shimmer like half-formed formulas. Every time you open the drawer, it whispers softly in van der Waals tones. Solubility is but a state of mind. Curious protons drift past like lost spirits, occasionally bonding with stray hydroxides to form ectoplasmic water. Ghostly precipitates appear and vanish. The pH meter refuses to go near it. And the smell? Pure memory. Legends say if you swirl it 3 times and chant a Lewis structure, you'll summon Schrodinger's cat, or at least some faint ammonia. Section 36. The Periodic Table's Family Reunion. Once every eon, the elements gather for a truly noble event, the periodic family reunion. The alkali metals arrive first, predictably eager and reactive. Noble gases show up fashionably late and refuse to mingle. The halogens bring drama, and the transition metals shine in over-accessorized d orbitals. Hydrogen can't decide which side of the table to sit on. Carbon mediates disputes with tetravalent diplomacy. And poor lanthanum and actinium, still arguing about who sits above whom in the F block. Unstable isotopes are kept at a safe distance with half-life name tags. And as the reunion winds down, everyone agrees to ionically bond over shared nostalgia and covalent gossip. Section 37. The Chaotic Neutral Buffer Solution. There exists a buffer that obeys no law, acknowledges no pKa, and fears no titration curve. It resists changes in pH, but only when it feels like it. Add strong acid, it shrugs. Add base, it giggles. Ask it to maintain a specific pH, and it replies, only on Tuesdays. This buffer was brewed in a flask made of uncertainty and seasoned with sarcasm. Even litmus paper is afraid to touch it. Once, a brave phenolphthalein tried to reveal its true nature and promptly turned chartreuse out of confusion. And still, it sits, stabilizing chaos, one molecule at a time. Section 38. The Drowsy Dance of Diatomic Duos. High above the clouds of combustion theory, the diatomic elements drift in lazy pairs, holding hands as they float through nonsensical skies. O2 twirls slowly, its double bond humming a lullaby. N2 does slow backflips in a triple bonded embrace. Cl2, ever the diva, practices synchronized sachets, leaving trails of imaginary chlorine sparkles. They don't react, they just vibe. A bond here, a vibration there. Everything stretching, bending, rotating in a dreamy ballet of molecular inertia. There's no direction, no endpoint, just the gentle orbit of sleepy electrons in the arms of their partner. And somewhere in the distance, fluorine sneezes and starts a chain reaction of ticklish giggles. Section 39. The Beaker Who Believed It Was a Volcano. One small beaker, mostly used for gentle stirring and accidental overboiling, decided one day it was destined for more. I contain multitudes, it declared, holding a teaspoon of lukewarm solution. I am not just for titrations, I am power incarnate. It filled itself with baking soda and vinegar, shook slightly, and fizzled out, politely. But it kept believing. It tried potassium permanganate once, even tried holding dry ice. Nothing exploded. But every bubble, every little puff, whispered encouragement. You're valid. You matter, even if you never overflow. And so the beaker sat, proud in its small chemical eruptions, dreaming big, bubbling soft. Section 40. The Zen of Zero-Point Energy. At the very bottom of molecular motion, nestled deep in the frozen heart of nonsense, lies zero-point energy. It is the sigh a molecule makes when it has nothing left to lose, but continues to vibrate gently just because. Even absolute zero cannot stop its dance. It's the ultimate shrug, the infinite nap, the eternal rocking of quantum cradles. No matter how cold, no matter how still, something always stirs, softly, slowly, invisibly. Zero-point energy does not ask questions. It simply is. And in that gentle hum, the universe takes a breath and then forgets what it was doing. Section 41. The Oxidation Number Lottery. Welcome to tonight's drawing of the Oxidation Number Lottery, where every atom takes a chance at changing its charge. The electrons are buzzing with anticipation, orbitals fluttering like nervous bingo cards. First number up, plus 3 factorial iron cheers quietly, rusts a little in celebration. Next, -2 factorial oxygen swoons, pretending she didn't already know. Hydrogen, always the wild card, teeters between +1 and -1, just depending on the mood of the molecule. There are no winners, only redox participants. And at the end, everyone exchanges electrons, shakes hands, and politely pretends they weren't reduced to tears. Section 42. The Elemental Zoo. In a quiet corner of the imaginary academic world, there's a zoo made entirely of elements. Sulfur curls up like a sleepy cat, smelling faintly of midnight and eggs. Mercury swims slowly in its glass tank, reflective and moody. Carbon climbs trees made of graphite, occasionally shape-shifting into diamonds, just to feel fancy. Fluorine is kept in a high-security enclosure, behind triple panes of sarcasm. Helium bounces around its enclosure, giggling at its own voice. Gold just lies in the sun, soaking up compliments and emitting no reactions. No one's caged. They just stay because the bonds are comforting. Section 43. The Solubility Tea Party. A gathering of solutes and solvents is underway in a porcelain beaker under a magnolia tree. Sugar dissolves sweetly into tea, while salt swirls into savory nonsense. Oil, invited out of pity, hovers awkwardly in droplets, murmuring, "I'm not really a mixer." A cube of calcium carbonate tries to join the conversation, but remains stubbornly intact. The hostess, a gracious acetone, serves tiny sandwiches made of intermolecular forces and crumpets shaped like van der Waals attractions. Shall we precipitate? Someone asks. No, whispers the tea. Let's just stay saturated forever. Section 44. The Orbital Salon. Deep within the atom, electrons gather for makeovers at the orbital salon. The s orbital is getting a minimalist trim, just a clean, spherical polish. The p orbitals argue about which direction is most flattering, x, y, or z. Meanwhile, the d orbitals lounge dramatically, insisting they invented asymmetry. There's gossip in the waiting area. Did you hear F orbital showed up to the gala with 7 lobes? Bold. Electrons flirt across shells, daring to jump energy levels just to impress each other. The stylist, a radiant photon, zips in and out, energizing electrons and dropping compliments in Planck-length syllables. Section 45. The day the lab coats revolted. It began with a single sleeve folding itself the wrong way. Then another coat, starched and silent, floated off the hook and refused to participate in another titration. They never thank us, the coats whispered. We catch the spills. We absorb the drama. Soon, goggles joined in, fogging up in protest. The Bunsen burners stayed cold. The test tubes played dead. The scientist returned from lunch to find the entire lab dressed in lab coats. Nothing else. No people. Just swirling, ghostly outerwear, performing silent, passive-aggressive chromatography. Somewhere, a clipboard sighed. Section 46. The polymers' existential crisis. Long and stretchy, made of repeating monomeric identity, a lonely polymer stared into its own chain and asked, "Who am I? Am I synthetic? Am I natural? Am I meant to be plastic? Or did fate curve me toward being rubber? I stretch, but do I bounce back?" Crosslinks offered advice. You're stronger than you think. Side groups murmured affirmations. But still, the polymer looped inwards, forming a helix of introspection, winding tighter and tighter until it just elastomered into quiet contemplation. Sometimes, even molecules need therapy. Section 47. The titration that never ended. In a quiet lab that may or may not exist, there is a burette that continues to drip, drop by drop. No one knows when it started. No one knows what it's titrating. The indicator has long since forgotten what color it's supposed to turn. The flask below has reached a state of philosophical saturation. The pH probe gave up, now floating in silent despair. But still, drip. Some say it's a metaphor. Others say it's a ghost reaction. All agree it's soothing, pointless, and gently acidic, just like dreams. Section 48, the reaction mechanism's vacation. One summer, the nucleophile said, "I need a break." The electrophile agreed. They packed their lone electron pairs and went to the coast, where nothing reacted and everything stayed in a state of gentle potential. Intermediates sipped umbrella drinks. Transition states wore sunglasses shaped like reaction arrows. Solvents lazily surrounded them with dipole-drenched breezes. Not a single collision had enough energy. Activation barriers lay flat, like sunbathers. Enzymes were told, "Please, no catalysis today." For once, even the mechanisms themselves dissolved into relaxation. Section 49, the reagents who fell in love. A bottle of ethyl acetate sat quietly on the shelf. One day, she noticed acetone on the other side, volatile, unpredictable, and absolutely dreamy. They exchanged glances across the solvent table. Slowly, evaporative tension rose. Vapor pressure increased. The air filled with imaginary perfume. They never mixed. Not really. But in their separate containers, they dreamed of forming azeotropes, of hydrogen bonding in some distant, romantic, nonpolar paradise. And late at night, under the hum of the fume hood, their caps clicked open just a little, just enough to share a scent. Section 50, the alchemist's regret. Long ago, before moles were measured or valence understood, an old alchemist stirred his beaker of nonsense. He whispered, "I seek gold," and dropped in peacock feathers, moonlight, and crushed disappointment. The solution fizzed dramatically, then turned a color no human had ever named. He tasted it, for reasons unknown. It was vaguely salty, probably due to chloride ions or the tears of hope. In the end, no gold appeared. But the alchemist smiled. "Sometimes," he said, "transmutation is just another word for letting go." And with that, he vanished into vapor, leaving behind one beautifully unnecessary reaction. Conclusion. The final precipitate. And so, dear listener, we arrive at the bottom of the beaker. The final precipitate has settled into a fine, philosophical dust. The last electron has sighed, content in its orbital. The Bunsen burner flickers softly in the distance, like the whisper of a half-remembered compound. We have swirled through solvents, dissolved into dreams, and reacted with absolutely nothing at all. Perhaps you feel a little heavier now, or lighter, or like a helium balloon tied to a neutron star. That's the beauty of nonsensical chemistry. It balances the equation of your imagination without ever using math. We didn't learn a thing tonight, and that, my friend, is a reaction worth celebrating. If you've enjoyed this completely inaccurate, thoroughly relaxing, and mildly unhinged exploration into the dreamscape of chemistry, I invite you now, gently, slowly, reverently, to press that like button. It's somewhere out there, perhaps floating in a cloud of noble gases, perhaps nestled between an ion and a sigh. And if you haven't already, consider subscribing. Join us on future journeys through nonsense and numbness. There's always room in the test tube for one more sleepy mind. Until next time, stay balanced, stay bonded, and remember, electrons are just little whispers in the cosmic lab of your heart. Good night and good non-reaction.